This lesson will be about theorems involving parallel lines. This is section 5-3 in your textbook. The essential question for this lesson is, what are some useful facts about parallel lines? Basically, we're going to find that parallel lines are used by engineers and architects in designing and constructing products and buildings. And we'll learn some facts that aid them in using parallel lines. The first theorem is theorem 5-8. This theorem states, if two lines are parallel, then all points on one line are equidistant from the other line. So what exactly does this mean? Well, let's assume that these two black lines are parallel. And let's assume that we're building ourselves a ladder. And then we could say that every rung of the ladder is going to be the same length, okay? So as we're adding rungs here, we'll know that each of them is the same length as the other, provided these outside black lines are indeed parallel. So this is something that's probably intuitive, but yet it is a theorem here, so that if you've got two lines parallel, then all points on one of the lines are equidistant from the other line. The next theorem is theorem 5-9. This theorem states, if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Now, to understand this theorem better, I'm going to suggest that you look in your textbook on page 179 and look at problem 1 under the classroom exercises. That will hopefully help to explain this theorem a little bit better. That's page 179, classroom exercises number 1. Now the next theorem is theorem 5-10. Theorem 5-10 states, a line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side. Now, what exactly does this mean? It might help if I draw a picture. So let's start by drawing ourselves a triangle. And let's say our triangle looks something like this. And let me use a different color here. Now, what this says is a line that contains the midpoint of one side of a triangle. Okay, where's the midpoint? Let's say the midpoint is right there, okay? So a line that goes through that point and is parallel to another side. So let's say that here's our line, and this line is parallel to this line. All right? So we know that this is equal to this, because that's the midpoint. So we have a line going through the midpoint of one side of a triangle. It's parallel to another side. What this theorem is saying is that this point over here is the midpoint of this side. So we know that this is equal to this. So that's what this theorem is saying. You've got a triangle, you have a line going through a midpoint of one side, it's parallel to another side, and if you extend it until it hits the third side of the triangle, it's going to hit the third side of the triangle at the midpoint of that side. Now the last theorem we're going to talk about is theorem 5-11. Now this theorem actually has two parts. Now this theorem states the segment that joins the midpoints of two sides of a triangle, 1 is parallel to the third side, and 2 is half as long as the third side. Well, again, let's discuss this via a picture. Let's say we've got a triangle here. And here's our triangle. All right, so what does this say? Okay, we're going to have a segment that joins the midpoints of two sides of a triangle. So let's see, we've got right here is a midpoint, and right here is a midpoint. Okay, because we know that this equals this, and this equals this. All right, so let's draw in our line that connects those two sides through the x's. All right, so there is your line. And what this is saying is that this blue line is parallel to this black line. It also is saying that AB is half of CD. So 1/2 CD is equal to AB. All right, now I would like you to do problems 2, 3, 4, and 5 of the classroom exercises on page 179 and post your answers in the Dropbox.